Hello everybody, my name is Tyler Nelson, and today for my video project I will have to teach you how to do calculus, specifically how to do the 2008 FRQ's third question. Now keep in mind that although today you're only able to use the calculator for the first two questions, back in 2008 it was for the first three. So for this specific problem you're allowed to use the calculator. So you should already have the sheet print out. I'm not going to read out the entire question. That would just be a waste of time. So let's start with the first problem, A. And so if you want to solve it, first you need to start out with the equation that they give you. V equals pi r squared times height. That tells us the volume, but obviously that's not useful. We want to find the derivative of h, the change in height. So why don't we do that? Find the derivative of both sides. So then we get v prime equals pi r squared h prime plus pi 2r r prime h prime. And so now you might be thinking, what in the world would we do with a mess of an equation like this? It's a lot of different variables. But then if you look in the sheet, you see that all of the information is already given to you, except for h prime, which is what we're trying to look for. It's always increasing at a rate of 2,000 cubic centimeters per minute. And the radius is 100. And h prime is what we're looking for, so we just leave that like that. Plus pi to 100. It gives us that the rate that the radius is increasing is 2.5. Oh, whoops. That's not supposed to be there. H, it's just regular h. Sorry if I tricked you. And height, oh, whoops, that's not it. Height is 0.5, so we can't forget to add that on to the end. So now we can solve all of this ugly mess, and we get 2,000 equals pi times 1, 4 zeros, h prime plus pi, and then 0.5, that cancels out. 0.5 times 2, that cancels out, and then 2.5, so that's 25. Or 25 pi. You could write it like that. That's probably the way that you're supposed to write it. And finish off that parenthesis. So, after that, we can continue simplifying. 2,000 minus 25 pi equals pi times 10,000. I should have flipped that. Times h prime. And then just divide the entire thing by that. And you should get 2,000 minus 25 pi, all of that, over 10,000 pi. And since nobody would like to solve that without a calculator, that's why you were given a calculator for this problem. And what you should get, if you try and simplify that, is h equals 0.003. 8 point is 0.0038, or you could round it up and it's 0.0039. Either of those two will get you a point when it's graded. So, now let's move on to the next one. For B, it's asking you when the maximum is. And the maximum is when dv over dt equals 0, because it's differentiable, and that's when maximums are in a differentiable equation. And so, we already know the equation for dv dt, and that equals 2,000. But we have to factor in the fact that we now have a new variable being introduced, and that's the rate that things are getting cleaned up. So then it's only increasing at this rate. So then now we need to find when that equals 0, which you probably could do in your head, but I'm going to write out just in case. And that's 5 equals root t, or t equals 25. Really simple. 25 minutes. You should always put units. Very simple. Alright, and then for the last problem, it's even more simple. Basically, you need to solve for what the value is at 25. Like, what is the absolute maximum given that the recovery device started when it was already at 60,000 meters. And so in order to find that, we obviously need to put 60,000 meters right here, because it's not going to be less than that because we're finding the maximum. And then we want to find the area between 0 and 25 of the rate. So that's 2,000 minus 400 root t. Don't forget the dt. And that is literally it. Alright, thanks. Bye.